Today I'm going to look at simultaneous equations and do an introduction. So what are simultaneous equations? Well, if we have one equation, y equals x plus something, then we have many values for that. But if we have two equations and they correspond in a particular point, then we're going to have a unique solution. I think it's best if I do an example. Y equals x plus 2. And first of all, I think we'll plot that. And I like to label them as usual. Now on this line there are many values of x which correspond to a value of y. There's no unique solution. So down here we'd have when x equals 8, y equals 10. When x equals 14, y will it'll be equal to 16. But now if we add a second equation, let's go y equals minus x plus 10, and we plot that one, we'll see what happens. So plus 10 is our intercept, which is there. And when x equals 10, so we'll have minus 10 plus 10, y is going to be 0. So there's our other point here. Just plot that. Okay. We can see that this point here where the lines cross is a unique solution. It satisfies both equations. They're simultaneous. So now let's have a look at what those values are. We have a value for x, which is 4, and a value for y, which is 6. Okay. Now you can't always draw a graph, and they wouldn't be necessarily that accurate, and usually in an exam you're asked to solve it algebraically. So let's look at that technique now, and we're going to use a thing called the elimination method. We manipulate the equations, maybe adding them or subtracting them or multiplying them and then adding and subtracting to eliminate one of these variables, either x or y, and by doing that we'll get an equation with just one variable, one unknown, with just some numbers on the other side, and we just have to manipulate that to find that value. We can then put that value back in to find the other variable. I think if I do it, it'll become a bit clearer. I like to label the equations, so let's call this one equation 1, and this one we'll call equation 2. Now looking at these equations, we have an x and we have a minus x. If I add these two equations together, just like we would do in an ordinary sum, these x's will disappear and we're left with y equals something. So let's try that and explain it. So we're going to say add 1 to 2. Okay, I'm going to write them out again. I will just put a bracket there and show you that we're adding. 10 add 2, 12. X add minus x, nothing. Y add y, 2y. 2y equals 12. So y equals 6. Substitute into 1. 6 equals x plus 2. Therefore 6 minus 2 equals x, which equals 4. And that's just what we found here. X equaled 4, y equals 6. There we go. Okay, that's the method. Let's Now do some more complicated ones. Okay, we've got these two equations. 4x plus 4y equals 20 and 2x plus 3y equals 13. I've called them 1 and 2. Now if we just take this equation from this one, we're still going to be left with 2x. 2x from there is, from 4x is 2x. So what we can do is we can multiply this equation by 2 first, which will give us 4x, and then take that from this equation. So let's just tell them what we're doing again. Equation 3. Okay, 2 times 2x, 4x. 2 times 3y, 6y. 2 13s, 26. And that's our equation 3. Now take equation 1 from equation 3. And now we write equation 1 underneath. Four x from 4x disappears. 4y from 6y, 2y. 26 minus 20, 6. Therefore, so y equals 3. Put into 1. So we're going to substitute it into 1 now. 4x plus 4 times 3. The value of y equals 20. 4 3s are 12. Take the 12 from the 20. 4x equals 8. Therefore, x equals 2. And that's the answer to that one. Y equals 3. X equals 2. Okay. If you want to do a quick check, you can check it in the second equation. Y equals 3, 3 3s are 9, x equals 2, 2 2s are 4, 4 plus 9, 13. Yeah, that works. We'll look at another one. Now this one. 2x plus 3y equals 6. That's equation 1. 4x plus 9y equals 15. That's equation 2. I think we just try it and see. So if you see me follow my reasoning on this, and we say take 3 from 2. So let's bring, there's our 2, isn't it? So let's do it like this. Four x minus 4x, no x's. 9y minus 6y, 3y. 15 minus 12, 3. Well, y must be 1. We put in, let's say equation 1, 2x plus 3 times 1 equals 6. Take the 3 from the 6. 2x equals 3. Therefore, x equals 3 over 2. So y equals 1, x equals 3 over 2. And another one. Okay, we got this question. 2x plus 3y equals 8, equation 1. 3x plus 2y equals 7, equation 2. Whatever I multiply this one by, the coefficients won't match up with this one. And likewise with this, whatever I multiply this by, it's not going to match up with this. But if I multiply equation 1 by 3, I'll end up with 6x. And if I multiply this equation by 2, I'll end up with 6x. And we should be able to do something then. So let's note that. So this one's going to be times 3. And this one times 2. We'll label them. Equation 3, equation 4. Okay, let's just produce them. So that one's going to be 6x and 3 times 3y, 9y, 3 times 8, 24. And the second equation, that's going to be 6x and 2 times 2y, 4y, 2 times 7, 14. I think we subtract them. I better label them. I said subtract, didn't I? So, right. 6x minus 6x, it goes. 9y minus 4y, 5y. 24 minus 14, 10. So y must be 2. And we'll put this in 1. (2x) plus 3 times 2, which is our y value, equals 8. Well, that's 6. 6 from 8, 2. 2x equals 2. So x equals 1. And we can show this on a graph. X equals 1. Y equals 2. Always good to check it in the second equation just to make sure it works. X equals 1, so we're going to be 3 times 1, 3, and the y is 2, 2 times 2, 4, 4 plus 3, 7, so it works. Okay, on to the final one. Y minus x equals 1, that's equation 1, and then we've got y equals x squared minus 3x plus 4, that'll be equation 2. So we've got a quadratic now. So what we'll do is we'll take this minus x to the other side, and we can say plus x gives equation 3. So that becomes y equals x plus 1. And we're subtracting this. Y minus y, 0. There's no x squared, so that x squared stays where he is. 3x minus x is going to be a minus 4x now, isn't it? And 4 minus 1 is going to be 3. And we should be able to factorise that. What two numbers multiply together to make 3? Well, it's 1 and 3, isn't it? Minus 1 times minus 3, because we've got to make this minus 4, and when we add them together that's going to make minus 4. So x equals +1 or x equals 3. And the easiest one to substitute this into is equation 1. And so when x equals 1, y minus 1 equals 1, so y must be 2. Or y equals, this is when x equals 3, look at this, y minus 3 equals 1, so y must be 4. I'll put the positive there. So that's using the elimination method. There is another method, the substitution method, most often used on more complex problems. Okay, that's it for this week. If you'd like to see some more problems using simultaneous equations, then do leave a comment, and if it's helpful, press the like button, and of course, if you wish, subscribe. Thank you very much.